Hey, good morning, guys. So I just wanted to give you a little run through of the assignment that I have posting today at 9:45. And so I'll quickly read the instructions. So we're going to do something that we did similar when we were looking at exponential functions. So with quadratic functions, I just kind of want you to explore what it looks like on a graph, a quadratic function. And so we are going to be using our observation journal that's kind of been tweaked to match quadratics. And we're going to be using Desmos graphing calculator, which I have a link right here for you, as well as your final activity is the Desmos classroom activity, where you use the information in the observation journal to help you complete the tasks. So to quickly read, include an observation activity where you need to access the Desmos calculator, use the calculator, follow the notes of the quadratic functions observation notes and fill them out completely. And then you can post them back in, either take a picture of them or upload them. And then, of course, complete the Desmos activity. And right here is the code to get into that activity, the class code, which you will need to enter and put in your name as well. So quickly, let me give you a little quick demonstration of what exactly I'm asking you to do. So first thing, we look over here at, this is the observation notes, and notice that I have that base quadratic formula, pretty simple. So all I'm asking you to do is look at that base formula, go to your Desmos calculator, and just enter that in. So y equals x squared, and you'll notice that it looks a parabola, which is what you would expect. There's some observations I want you to make. First of all, that the fact that it is touching the x-axis right here on the 0, 0, it goes up equally on both sides. And so in your observation journal, I can't do that right now with my computer, but you would draw a little parabola right there. And then maybe in this side, you make a note that says if I can spell, the parabola touches the x-axis at 0, 0 coordinate. It goes up equally on both sides, okay? And so that's all I have to put. And so then my next task, and I'll do this one with you as well, it says, okay, so using this base formula, why don't you enter it in y equals negative x squared? So I'll go back to my Desmos calculator, and I'm not going to change this one. I want to compare it to that one. So I'm going to do y equals negative x squared, and then I look and observe how that changes. Okay, so now it's doing basically the exact same shape. It's touching at the exact same point, except it's now going indefinitely downward. Okay, so go back to my notes, and I will draw it as best I can. And then I look at this and say, okay, well, what changed? Well, I need to circle one. Did it translate left to right? Did it go left to right? Well, no, it didn't go left to right. It just went opposite, right? Did it translate up or down? Now, translate means that it doesn't change the direction, it just moves a certain direction. And so it definitely did not do that. Did it reflect over the x-axis? That's the one. Because right here you can see this is the direct reflection of the original equation. So I would, in this case, I'm going to highlight that, but you would on a piece of paper just basically circle it. Okay. And so then you move on down and then notice that I did x plus 4. And so you just make note of how to look at that. Cool. Hopefully you guys can do this pretty easily and just kind of, my whole point of this is just to get you familiar with the look of it and how simple things to the equation can change the shape, direction, and position of each parabola. We will apply this to math, of course, next week. All right. All right, guys, so I'm going to show you how to get into the game. First of all, I click on this, making sure that I remember my code. I jump on, and here we have V37AJJ. Okay, so I hit join. And then once it loads up, I can sign in with my Google account, and I'll just do mine real quick. Yes, so it kind of started already, but just so you know, this is kind of how it looks. Welcome. So they want you to basically plot a parabola that hits points that they give you on a graph. So here, let's show this first one. So this looks very familiar to the very base equation that I gave you on those notes. And so I know that just because I know that the 0 is where the first coordinate is, and that's where it touches the x-axis and goes up. So I can just enter in and then it pops up perfectly. And that's what you're looking for. You're looking for the parabola to hit perfectly into that each of those points. And then I submit it and I can kind of move on. And so I'm asking you to just continue to go on through these slides as far as you can go. You can see that these are all pretty similar. And then if you looked at the observation notes, you would know how to move left or right, how to translate it left or right, or how to translate it up or down. We can see by the position of those dots that we're not reflecting, so there's no negative. And so, for example, the blue, let's see here. Let's see if I can kind of just play with it and see what I can do. So x squared, let's say, plus 4. Does that look? Let's check my work. So I went a little too high. It looks like it's not on 4, it touches on the 3. So I'm going to bring it down to 3 and check my work, and there it is. Okay, then I move on to the green and so on. All right, so just going to play with it, try to have fun and explore the changes, how you can manipulate the equation to get different positions and shapes on the graph. Okay, have fun.